Types of storms. Common types of storms explained. The following are some of the most common types of damaging storms in the U.S. to be prepared. Check your insurance policy and make sure you are covered for all the types of storms that affect your areas. Flooding and earthquakes are not covered by most insurance policies, but hail, windstorms, tornadoes, and hurricanes are typically covered by most insurance. It is always a good idea to check your individual policy and have a good understanding of your level of protection, and purchase additional protection if necessary. Hail storms. Many residents living in the U.S. have already experienced a severe hailstorm and witnessed the damage hail can cause to homes, automobiles, businesses, and other property. When a hailstorm hits, it does the greatest amount of damage to the exterior of your home or property. Common types of damage caused by hail are roof damage, siding damage, shingle damage, window damage, and automobile damage. Thunderstorms. Thunderstorms can produce many types of damaging weather such as lightning, hail, tornadoes, straight-line winds, flooding, and more. The biggest contributors to damaged property are likely hail and wind, which can cause many types of exterior property damage. Ice storms. Ice storms produce freezing rain that coats everything in its path with a layer of glaze ice. Generally speaking, if a storm causes accumulation of more than a quarter inch on exposed surfaces, the storm can be classified as an ice storm. This type of accumulation can cause broken tree branches, power outages, and other hazardous conditions. Tornadoes. For many areas around the U.S., damage from severe tornadoes presents a very real threat. Most tornado damage is done by high winds, with recorded speeds exceeding 300 miles per hour and the flying debris propelled by these fierce winds. The most damage from tornadoes happens in Tornado Alley, a part of the U.S. that includes Oklahoma, Texas, Kansas, Missouri, etc. Lightning. You may be surprised to learn that lightning is a major cause of storm damage in many areas around the country. The National Lightning Safety Institute estimates the cost of lightning damage in the $5 to $6 billion per year range. Lightning that hits trees and the ground is a common cause of wildfires, structure fires, property damage, and power outages. Heavy snow, blizzards. Blizzards are severe winter storms that combine heavy snowfall with high winds and freezing temperatures. The combination of cold, wind, and snow damages homes, businesses, and automobiles. Heavy snow can produce dangerous conditions, including roof collapse. Floods. Floods are typically the result of heavy rain and water that rises faster than storm drains can handle. Flash floods driven by quick, violent bursts of rain can flood homes, basements, and businesses, causing serious damage to both interiors and exteriors. Flooding is a very dangerous storm phenomenon that results in numerous deaths and extensive property damage each year. A derecho is a large, violent, fast-moving, complex of thunderstorms that follow one another along a path of at least 240 miles, with wind gusts of at least 58 miles per hour. Although derechos are very difficult to predict, they often form along the boundary of a large, hot air mass near a jet stream air current. Tropical storms. A tropical storm is a type of storm system that develops in tropical environments. These storms are characterized by extremely low pressure systems and high-speed, swirling winds. In order for a storm to be classified as a tropical storm, a specific set of circumstances must exist. In order to be a tropical storm, the wind speed must be between 39 and 73 miles per hour. Lower or higher wind speeds would be another classification. Lower, tropical depression; higher, hurricane. Hurricanes. A hurricane is the most powerful classification given to a tropical cyclone. Characterized by low barometric pressure systems, extremely high winds, heavy rainfall and storm surges and swells, hurricanes that make landfall can be extremely destructive. Tsunami. Tsunami waves originate with the occurrence of a forceful vertical motion that causes the water column to fall or rise suddenly. Comparable to the wave that is formed when a hand is plunged abruptly into water. Tsunamis are most commonly triggered by earthquakes that result from the motion of continental plates. If the continental plates simply slide horizontally against one another without one being thrust above the other, however, the overlying water column does not receive the strong vertical impulse necessary to create such a wave. But if the plates rise or fall relative to one another, the water surface is correspondingly lifted or lowered, thus producing a tsunami. These kinds of motions occur most commonly in the vicinity of subduction zones, where one continental plate is thrust beneath another. Formation of a tsunami, therefore, does not depend necessarily on the intensity of an earthquake. There have been earthquakes measured with magnitudes of 8 or 9 that did not trigger tsunamis. By contrast, relatively weak earthquakes have been known to produce large tsunamis. Sophisticated computer models are now being applied in attempts to better understand the special characteristics of earthquakes that are particularly relevant to the development of tsunamis. Unlike waves at the water surface, which are produced by wind, a tsunami wave involves motion through the entire water column continuously from the site of its origin. At great depths it can propagate unimpeded, and at a water depth of 5,000 meters can attain speeds of up to 800 kilometers per hour. The character of its propagation can be described with some confidence using mathematical physical wave models. But when the wave encounters a continental slope or the shore, its progress is slowed, causing it to rise up vertically. How the tsunami develops from this point on depends upon the shape of the coast, and is much more difficult to describe mathematically. It is therefore almost impossible to accurately predict the wave height when it strikes land. Before a tsunami hits a coast, the water there initially retreats. This sequence of retreating water and surging surf can also be observed in the normal wave motion on a beach, whereby this motion is, of course, significantly smaller. Earthquakes. Earthquakes are usually caused when rock underground suddenly breaks along a fault. This sudden release of energy causes the seismic waves that make the ground shake. When two blocks of rock or two plates are rubbing against each other, they stick a little. They don't just slide smoothly. The rocks catch on each other. The rocks are still pushing against each other, but not moving. After a while, the rocks break because of all the pressure that's built up. When the rocks break, the earthquake occurs. During the earthquake and afterward, the plates or blocks of rock start moving. And they continue to move until they get stuck again. The spot underground where the rock breaks is called the focus of the earthquake. The place right above the focus, on top of the ground, is called the epicenter of the earthquake. These explosions may be set off to break rock while making tunnels for roads, railroads, subways, or mines. These explosions, however, don't cause very strong seismic waves. You may not even feel them. Sometimes seismic waves occur when the roof or walls of a mine collapse. These can sometimes be felt by people near the mine. The largest underground explosions, from tests of nuclear warheads, bombs, can create seismic waves very much like large earthquakes. This fact has been exploited as a means to enforce the global nuclear test ban, because no nuclear warhead can be detonated on Earth without producing such seismic waves.